If you turn this video off, please tell me what the reason was so that I can improve. Otherwise, hi and welcome. I'm trying to learn electrical engineering today, electrolysis, and after we've done it, we're gonna do standing yoga. And if you participate in the standing yoga, then is it at your own risk. Electrolysis. It will help you to understand some of the basic ideas we have already considered if 3 examples of electrolysis are considered in detail. A. Dilute sulfuric acid between platinum electrodes. The ions present in the electrolyte are hydrogen ions, sulfate ions and hydroxyl ions. When a current flows through the voltmeter, these ions migrate to the electrodes. At the anode, OH- and SO4 are available, but only the OH ions are discharged at this, as this involves the minimum energy change. Okay, we're having 2 electrodes out of platinum, and in between them is our dilute sulfuric acid. They are plunged into it, and that contains hydrogen. So we have something with the H. We have OH- hydrogen. There could be the HN. We have sulfate ions, maybe the SO, and hydroxyl ions. So we're having again something with H, but oxyl, so we're having oxygen somewhere as well. So we have something to do with the OH- and the SO4. We're having 2 platinum inside of it. And at the anode, there is OH- and SO4. But only the OH- ions are discharged at this, as this involves the minimum energy change. It is interesting. That means both substances going there, but they having one is easier to react than the other one, and therefore just the one is doing it right now. 4 OH- minus 4 electrons equals 2 H2O plus O2. The oxygen gas is given off at the anode. At the cathode, H plus only are available and are discharged. 4H plus 4 electrons equals 2H2. Okay, at the anode and at the cathode things are happening. These anode and cathode are with 2 platinum plates. And the current runs, I still don't get it, there was something turning on from the anode to the cathode. And it goes to the anode, and there 4 electrons are given away, and now it runs to the cathode, and there 4 electrons are given to it. And that is at least the way the electrons are brought back and are given to it and taken. And that is the way the current is running, because the electrons are transported to somewhere. So we're having our 2 platinum plates in it, and at some plates at the anode, where the electrons are given or taken, and at the other place they are given and taken to the substance, our dilute sulfuric acid, and that the electrons are transported, and that's flowing current. The hydrogen gas is given off at the cathode. In the electrolyte, the number of sulfate ions present remains unchanged, and hydrogen ions are freely available from the water. Hence, the electrolyte remains dilute sulfuric acid of the same concentration. In effect, the water is electrolyzed and not the acid. I don't really know what they want to explain us. Okay, let's read on. Number B. Dilute hydrochloric acid between carbon electrons. Okay, that is the difference. We have here platinum. Now we had platinum electrodes, platinum plates. Now we're having carbon, and I think now because we have carbon, it will react differently, because things react with other things. Some things don't react with other things, other things do. Sometimes you can have an acid in a glass bottle and it stays there forever peacefully. If you have that acid somewhere else, on flesh or something, it will make it away. So basically, some substances reacting with some substances, but not with others. And now, if we had our platinum plates, that was possible that at the one, the dilute sulfuric acid was doing exchange, and at the other one not. And that had the effect that the water is electrolyzed, that it gets electrons or something, but the acid not. Because the acid is not reacting with platinum, maybe because it's these special type of metals. but with water was electrolyzed. We're talking about something like that. I don't really know what they want to explain to us, and I don't understand what they are explaining. But let's do it. Dilute hydrochloric acid between carbon electrolytes. The ions present are H+, Hl-, and OH-. At the anode, Hi- and OH- ions are available, and the chloride ions are selectively discharged, as less energy is required to do this than to discharge hydroxyl ions. Okay, the chloride ions, they are going there to the one carbon plate and are bringing the charge of the electrons. But the hydroxyl ions are not doing that because they need more energy to do that step. 2 chloride ions minus 2 electrons equals chloride 2. Chlorine gas is now given off. At the cathode, hydrogen ions are available. 2H plus 2 electrons equals H2. Hydrogen gas is given off, equal in volume to the chlorine. In the electrolyte, the number of chloride ions is reduced by the electrolysis. So the concentration of the acid is reduced. The acid is being electrolyzed and not the water. Okay, we're having other substances, and they said the chloride ions, the chloride acid probably. We have hydrochloric acid. So we have something with chloride and acid in it. And the chloride acid is given off its charge, but not the hydroxyl ions. So the chlorine gas is given off its electrons, and because it gives off its electrons, it gets less acidity. Hydrogen gas is something also happening. Whatever, the acid gives off electrons, and therefore the acid concentration gets lower. But not the water, because the water, I don't know. C. Copper sulfate solution between copper electrodes. The ions present are Cu++, H+, OH-, and SO4 at the anode. OH- and SO4 ions have migrated towards the anode, but neither of these types of ion lose their charge. Instead, some atoms in the copper anode lose 2 electrons, each to form copper ions which pass into the solution. Okay, now the copper plates are seeming to dissolve. At the cathode, the choice here lies between the copper ions and the hydrogen ions, both with positive charges and called cations, because they both migrate towards the cathode. The copper ions are selectively discharged, causing the cathode to become coated with a layer of additional copper. So the one copper plate at the anode, I think the copper plate is dissolving, but the copper is transported over to the other copper plate and they have run on again. I think it makes in a way sense, because we had the one type of ions going there, and some ions going there, and they were reacting, taking the copper, and then we're going over to the cathode, and where the copper is reacting with the copper. Something, I don't get it. Copper ions in the electrolyte. Copper ions are removed from the anode to enter the solution, and an equal number of copper ions leave the solution to be deposited on the cathode. The solution of copper sulfate remains unchanged in composition and concentration during electrolysis. Okay. Practical applications of electrolysis. Oxygen, hydrogen, and chlorine gases are all produced commercially by electrolysis, although the 2 former gases are produced more cheaply and on a larger scale by other methods. I don't know what former means. The first one, oxygen and hydrogen. Consideration of the electrolysis of copper sulfate solution between copper electrodes will suggest to you that this forms the basis of the process known as electroplating. I never heard of that before. For example, A brass spoon could be nickel plated by filling the plating bath with nickel sulfate solution and providing a bar of pure nickel at the anode. I don't know what a brass is. A brass spoon, so I'm thinking it's a spoon. It could be nickel plated. What does it mean? It has nickel. It has a plating bath. By filling a plating bath with nickel sulfate solutions. We have a spoon and we want to make that spoon full of nickel or with nickel surrounded. I think that is what it's saying. So a brass spoon could be nickel plated. We want to put at the top of our spoon nickel. By filling the plating bath, we're having a bath of nickel with nickel sulfate solution and providing a bar of pure nickel at the anode. Okay, we're having a spoon and we're having a solution of nickel. And we're having a bar of pure nickel at our anode. Articles are chromium plated and silver plated in a similar sort of way. It should be pointed out that the choice of salt in a particular plating bath, the concentration of temperature of the electrolyte, the actual material to be plated, the cleanliness of the surface and the size of the current used are all factors which affect the final result. Much trial and error is often required before successful electroplating can be carried out in the laboratory. Okay, we're doing the following. We're having a spoon and we're having a bowl full of nickel, liquid nickel. And now we're having at one side the anode, at the other side the cathode. And at the anode we're having a block of nickel. When we put now our spoon in and putting current in it, then some types of thing of this solution, taking the nickel from the nickel plate, putting it into the water and putting it to the cathode. But the cathode is in this place now our spoon. Our spoon seems to be working as the cathode. And now this these nickel elements are going from our nickel block into the water and from the nickel solution water to our spoon. And we're starting to accumulate as a plate on top of our spoon. We have a bowl full of nickel, on one side a nickel block. We're putting our spoon in, the current flows from the block to the spoon, and whatever takes the nickel from that block puts it into the solution, but the nickel reacts then with the spoon and goes then onto the spoon. I think we understood at least the practical way of it. Maybe not what is exactly happening there now, but we understood what is happening and how to make a spoon full of nickel. I don't know why, but maybe that helps to let it not foul away or whatever spoons are doing. I don't know the name for it. That was the particle physics part. If you were here for particle physics, you can go directly to the next part of that was not particle physics, that was electrical engineering. If you were here for electrical engineering, you can go directly to the next part of electrical engineering. If you stay here and participate in our 2-minute yoga, then it's very out. Having the feet standing together, and we're doing a sprouting flower. Breathe in and lift the arms up. Hold it down. In up. Hold it down. One more time, in and up. Out on to the side. In and up. Out on to the side. In and up. Inch space between the feet. Out on to the side. In and up. Out and sink down. In and up. Out on to the side. In and up. Out and down. In and up. Out the hands onto the knees. Breathe again in. Out, make a hill with the back. In into the middle. Out the belly with the back. In into the middle. Out the hill with the back. In into the middle. Out the belly. In into the middle. And out come with the round back up and make it the top backwards shoulder round. Breathe in, lift the arms up. Breathe out up to the side. Breathe in and up, come up onto tiptoes. Breathe out and go down. This can go to the knees. Breathe in, come halfway up. Higher up and out and up. Breathe in, reach high. Breathe out onto the side, down with the heels. In again, up into the heels. Out and down. Breathe in, come halfway up. Higher up and out and down. Breathe in, reach high. Out and down with the hands down, feet again. Breathe in, bend the right leg. Breathe out, stretch left leg. In and change. Out, stretch the right one. In and change. Out the left one. In and change. Out the right one. Breathe in into the middle. And out comes slowly with a round back. Up and back at the top. Backward shoulder. Breathe in, lift the arms up. Up across the arms, intertwine the fingers. Breathe in, reach high. Breathe out, reach in front. In and up. Up across the upper arm, breathe in, reach high. Out and front. In and up. Out, draw the shoulder blades together. In and up. Out with long arms back. In and up. Out the arms down. Breathe in with the arms up. Bring the hands together and lower the hands down to heart center. That was a 2-minute yoga. I thank you very much and until next time.